Today's video is going to go over arc length, and I believe this is a nice break from all the integration techniques that we've been trying to learn and memorize because it's fairly simple in comparison to like trigonometric substitution. And the closest thing to any previous lesson we've had with arc length, in my opinion, is disc and washer method because it's basically just memorizing a formula and plugging it in. But in this case, I feel like it's a lot easier because it's a pretty straightforward formula where our length is equal to the integral of the square root of 1 plus dy over dx squared from a to b dx. And this dy over dx is just an expanded way of just saying y prime, or the derivative of the y function as given here. So basically once you find your derivative, you just plug it into this parentheses. And just like disc and washer method, it's dependent on what bounds you're given. So you can also have an x equals g of y instead of a y equals f of x, depending on what variables you're given. And I will demonstrate both here. And if you're curious as to what arc length is, it's basically just getting 2 points on a curve. And over here I just drew a sun. So 2 points of a curve, like over here and here and here and here, and just finding the distance between the 2 points. So our first problem will be to find the arc length of y equals 1/3 times x to the 3/2, given the bounds x equals 0 and x equals 4. So your first step is just going to be finding the derivative of your y, which is just 1/2 x to the 1/2. And again, all I did was take the derivative of the y equals function, which is 1/3 x 3/2, and then plug all of our information into our first formula because we are given y equals, as well as our bounds being in terms of x. So plugging in gets us L equals the integral of 1 plus 1/2 x to the 1/2, all under a square root dx. And don't forget to square our dy over dx, bounded from 0 to 4. Now when we simplify, we get integral from 0 to 4 of 1 plus x over 4 dx. From here you could perform a simple u substitution where we could set our u to equal 1 plus x over 4, which makes our du just 1/4 dx, which then makes our dx equal to 4 du. Now never forget about our u substitution rules, where our bounds will change in accordance to u. So our lower bound becomes 1 and our upper bound becomes 2. And now we just have the square root of u times 4 du. And again, all I did was just plug in these terms into our integral. We can then take out our 4 and rewrite this square root of u as u to the 1/2, which finally gets us 4 times 2/3 u to the 3/2 bounded by 1 to 2. And you can take out this 2/3, making this 8 over 3 times u to the 3/2 bounded from 1 to 2. And this definite integral becomes fairly easy, which gets us 8/3 times 2 to the 3/2 minus 1 to the 3/2, which simplified leaves our final answer to be 8/3 times 2 times the square root of 2 minus 1. And that was problem 1. I would now like you to do this second one on your own. Now, if you're intimidated by this inequality, don't. This is the equivalent of just saying our bounds are y equals 1 and y equals 2. And notice that all of our terms are in y, so we are going to be using this formula. So the easiest way to approach this is just to solve for the inside of the square root, but to do that, we also need to solve our dx of dy. And again, the equivalent of dx over dy is just finding the derivative of our x function, which is this whole thing. Now, once you finish deriving this entire equation, all you end up getting is y minus 1 over 4y, which is our dx over dy. So now we have something to plug in there, giving us y squared minus 1/2 plus 1 over 16y squared. Now again, this is just our inner function inside the parentheses over here because we squared it. So now we have to add this 1 over here. So 1 plus, and then this inner function, which simply gets us y squared plus 1/2 plus 1 over 16y squared. Now to make things simple, you have to recognize that this is a perfect square because this is equivalent to y plus 1 over 4y times y plus 1 over 4y. So if you merge those together, you get y plus 1 over 4y squared. And again, this entire thing solved for the inside of the square root over here, which has so many arrows. So bringing this back down, we could pretend like we're plugging this guy in here, which gets us L equals the integral of the square root of y plus 1 over 4y squared. And remember, our bounds are equal to y equals 1 and y equals 2, which is our lower and upper, so 1 to 2. And of course, the square root and the square cancel each other out, so we're left with L equals the integral of y plus 1 over 4y bounded from 1 to 2 dy. Now we can evaluate each integral, with our first part being y squared over 2 bounded from 1 to 2, and then the second part part, which is 1/4 times the natural logarithm of the absolute value y, bounded from 1 to 2. And that's just a definite integral that you can solve, which lands you at an answer of 3/2 plus 1/4 natural logarithm of 2. And you can always just remove that absolute value since you already know that it's a positive number, so you could just say natural logarithm of 2. And that is our final answer. Thank you for watching.